All right, continuing on with section 5.3, we just looked at this example here. We found this typo in our notes where this should have been focus, not vertex. And making all these changes so that next year they'll all be fixed. Oh, I didn't do that last year, or didn't find them last year. I think I revised these last year, so that's when the typos happened. And I just didn't find them till now. Okay, here's our formula sheet that I gave to you before our last test. So for our chapter 4 test, we had these 3 formulas, right? This was chapter 4. So we have our continuous interest, our growth and decay, and this is our compounded interest. Then we have these formulas, which are for sequences and series, and those will all be part of chapter 7. This is having to do with the binomial theorem. It looks really ugly, but we're going to learn a much easier way to deal with it, so don't let it scare you. Alright, so here's our chapter 5 formulas. So this is the circle formula we just talked about in section 5.2. And then these 2 formulas are our parabolas. So 5.3, so these are the parabolas. So this one is either going up or down if negative, right? And this one is right or left if negative. So those go sideways and those go up and down. So those are the formulas you're given. In class the other day we looked at this ugly thing. We'll come back to this. Let's try to keep this more simple at first. So we've got x minus h squared equals 4p y minus k, right? And this is opens upward or downward. So it's going to be like this or this if we have a negative 4p, right? And of course our vertex is at hk. And then for the focus, it's just going to change the y value, right? So the focus will stay at h, but then k will be affected by p. So maybe we should think of this as, I think this will simplify a little bit. Just trying to figure out a way to make this more simple from what we did in class the other day. So if p is negative, meaning this whole thing right here is negative. So if p is negative, then that would mean that you're adding a negative value to k, and it would take your focus down instead of up, right? And then of course your directrix would be at y equals the opposite of that. So whatever k is, and then minus p, so it's the opposite direction. So if p was already negative, that would be adding that to k, and it would be up here. Does that seem more simple, or is that just more complicated? Okay, let's go the other direction with our other formula. So that would be y minus k squared equals 4p times x minus h. So pay attention to the fact that h and k are switched, because k is always with y and h is always with x. Because when I'm in a hurry and not paying attention, I accidentally write them down in the order they appear, so then I would make that the x value and not the y value, and that would be wrong. Okay, so these are normally opening to the right or opening to the left if we have a negative p, right? So then our vertex again is at hk. Don't forget that that's the opposite of how they're written, right? So maybe I'll just make a little line, doopy-doopy-doo, that one's there, and doopy-doopy-doo, that one's there. Okay, So then we have our focus, and this time the focus is changed on the x value. So it would be h plus p and k if p is positive, so it's to the right of the vertex. And then the directrix, or if p was negative, then that would be a negative value, so it would move it to the left of the vertex. And if the directrix is now going to be a vertical line, so it's going to be x equals, and it's going to be that h value minus the p. So if p is positive, it's subtracting, and if p is negative, it's subtracting a negative p, which will be the effect of adding p, which moves that over to the right, like that, right? Something like that. Okay, so here is what we looked at the other day. Is we kind of did all four situations where we have positive 4p, the negative 4p. It's got the same information, it's just splitting up into the four different situations instead of just the two adapted with the negative that happens. I don't know. This just looked messy and overwhelming, so I just thought we'd go through it with just the two formulas that are on your formula sheet, instead of splitting it up into four. Okay, let's do these examples. So clear this out so that we can start over. Okay, graph the parabola given by the equation x plus 1 squared equals 8 times y minus 3. Find the focus, directrix, and the length of the lattice rectangle. So we're going to go find h and k. So it doesn't say find the vertex, but I feel like that's a given. So the vertex is going to be at -1, that's with the x value, +3, because that's with the y value, right? And then we have this 8 here, so that's the length of the segment that goes across through the focus, we call the lattice rectum, so that's the 8 value. And then we want to find probably the p, the focal length, right? So 4 times p is 8, so p would have to be 2, so that's our focal length. It doesn't specifically ask for that. There it is anyway, because we need it for our focus and our directrix. So the focus, because p is positive, is going to just be added to the y value. So I'm just going to take 3 plus 2. So that would give me 5. And then the directrix would be subtracted. So it's a y equals, it'll just be a horizontal line because this one opens upward. So y equals, it's going to be in the opposite direction. So this time we're going to go 3 minus 2. So we get y equals 1 for our directrix. Okay, let's put that all in a graph. So left 1 up 3, the opposite numbers of the numbers in our equation. And then our focus is going to be left 1 up 5. And our directrix will be down here at 1. And then right here, the length is 8. So we would go left 4 and right 4, giving us a total distance of 8. So 4 on each side of that axis of symmetry. So then our parabola, oops, I totally missed that point. Let's try that again. I don't think that was any better, because now I missed this point. Okay, so you get the general idea.